Hi friends, welcome to Unacademy. Hi friends, welcome to Unacademy, India's largest learning and teaching platform. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who wants to write CET exam in the year 2021 can subscribe the plus courses. What are the benefits of plus courses? First of all, students, you can apply this course for a very much low cost. It's of affordable price. This course also comprises of structured live courses. Both class 11 and class 12 topics will be done in detail. All the important essential concepts, sub-concepts and also the previous year questions will be done in detail. The tricks, tips and necessary formulas will be shared during these classes. There will be also dedicated live doubt clearing session. Students, in case if you have a doubt regarding a particular concept or a topic, you can clarify all your doubts during these doubt clearing session. Apart from that, you will also have quizzes, students. In case if you have completed and a particular topic and you want to analyze yourself whether you have studied it well, whether some more studies required, so you can go for quizzes that will help you for self-analysis. Different kinds of batches we have, so whichever is convenient for you, whichever is appropriate for you, you can join that batch. But while joining, kindly make use of this code BHAVANILIVE and get the maximum discount. You will also given practice paper, daily practice paper, so that you can practice the papers, so that you keep on studying the subject. You don't forget a particular subject. There will be also full-length mock tests. All these are with analysis. So single subscription student, you will have unlimited access. So plenty of educators. You will have number of batches, hundreds of courses and thousands of lessons. All these are happening every day under the roof plus Unacademy Plus. So you can be a part of this, or you can inform your juniors, your youngsters, or all those who wish to do well in the CET exam. As you can see, we have a comprehensive batch which is for 8 months. Okay, so the entire syllabus will be done. And you will also have a Kannada batch. So if you are comfortable with Kannada and if you feel like joining the Kannada batch, you can do so. It's a 6-month batch, okay, where you will have the entire syllabus will be done in 6 months. We have different plans, like a few of the plans are 12 months plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125. You also have a champions batch for the year 2021. You will have different combinations: PCM, PCMB, PCB. So this has started from 15th of October. In case if you are interested, you can join this batch. But while enrolling, make use of the code BHAVANILIVE and you get the discount. There are also students free practice tests for Karnataka CET exam, which has started from 2nd of November. You can enroll your name for the test. See to it that you are learning and then you are writing the test. Okay, so this will be a live test which you will be answering. This will give you a very good practice for the CET exam. Before you write the CET exam, this will give you a very good practice, students. And students, I hope you know I'm Bhavani, so you will be I think not only watching my YouTube session, but I'm sure that you are also watching my special classes. Okay, students, whenever you like my YouTube classes, kindly press the like button and also press the bell icon so that you get further notifications. You also see the description box and you see the link for my classes, and also do not forget to like and also share these videos among your friends. You need to share the videos and also see to it that you are also watching the special classes, the free classes what is given under Unacademy. So kindly join those classes also. Usually I take those classes at 10 o'clock, morning 10 o'clock. So you can be a part of these special classes also. And students, as far as possible, you motivate your friends also and inform them also about these classes. And do not forget to subscribe the YouTube channel. Kindly subscribe the YouTube channel and also watch all these classes, whether it is the YouTube classes or whether it is the special classes. See to it that all the classes are attended and you are getting maximum benefit of the these classes. So today we are going to continue with the previous session. We have been actually going through questions on P block element. I have told you S block, P block, D and F block, these are all very important topics for your competitive level exam. So you should be reading the NCERT textbook very well, and then you are going with the competitive level books. Read line to line, start working on the questions, in-text, exercise, and also what is there in the exemplar, and then go through all the previous year question paper and also see any of the competitive level book. But then initially you have to go through NCERT textbook. So we'll begin with today's class. We will have question number 1. Let us see question number 1. Which statement is wrong? So there are 4 statements given. You have to pick the one which is a wrong statement. Beryl is an example of cyclic silicate. Option A. Option B. Mg2SiO4 is orthosilicate. Option C. Basic structural unit in silicate is the SiO4 tetrahedron. Option D. Feldspars are not aluminosilicate. So among the 4 options, which is the wrong statement, student? Students, you can give your answer. You can give your answer in the comment box if you are aware of the answer among 4 options. Now, beryl is an example of cyclic silicate. So, is it a cyclic silicate? Students, you can see here, this is beryl, what I am showing now, and as you can see, it is a cyclic silicate. It is in a cyclic form. So, first option is the right option. It's not a wrong option. Mg2SiO4 is orthosilicate. Of course, isn't it? There is only one SiO4 unit. It is a orthosilicate. Basic structural unit in silicate is SiO4 tetrahedron. If you see any of the silicates here, the basic unit will be SiO4 minus, isn't it? So this is the actually the basic unit, the structural unit of silicate, SiO4 4 minus in a tetrahedral manner. So option 3 is also the right option. Feldspars are aluminosilicates. Now feldspars are not aluminosilicate, it is given. Now look at the structure of feldspar. As you can see here, in these, this is silicon and the black color one sphere is aluminium. So in this structure, in feldspar, some of the silicon atom, you can see here, the black one, you can see here, some of the silicon atoms have been replaced by aluminium. First of all, what are aluminosilicates? Aluminosilicates means aluminium atom replaces the silicon atoms. Few of the silicon atoms are replaced by aluminium atom in the 3D structure of SiO2. In the three-dimensional structure of SiO2, few of the silicon atoms are replaced by, you can see here, are replaced by aluminium. That is called aluminosilicate. And what you see here is feldspar, where silicon is replaced by aluminium. So naturally it is a aluminosilicate. Whether it is a feldspar or is it, it's a zeolite, both are aluminosilicate. So this option, that is option D, is the wrong answer. Okay, this is a wrong statement. That means it is the answer for our question, because we need to pick option which is wrong. Okay, so I hope students you have understood. Go to question number 2. Which of the following statement is incorrect? Once again you need to pick an incorrect statement. Option A, pure sodium metal dissolves in liquid ammonia to give blue solution. Option B, NaOH react with glass to give sodium silicate. Option C, aluminium react with excess of NaOH to give aluminium hydroxide. Option D, sodium hydrogen carbonate on heating gives sodium carbonate. So among the 4 options, which is the incorrect statement? So students, if you have answer, you can write it in the comment box. Whether it is option A, is it B, or is it C, or is it D? Which is the right answer? You have to find out incorrect statement. Now we will pick option A. Pure sodium metal dissolves in liquid ammonia to give blue solution. Whether it is alkali metal or whether it is alkaline earth metal. It can be alkali metal like sodium, or it can be alkaline earth metal that dissolve in liquid ammonia. That dissolve in liquid ammonia to give, you will get NH3X plus and ENH3Y minus. When alkali metals dissolves in liquid ammonia, they give ammoniated electron. These ammoniated electron absorb energy from the visible light, student, and impart blue color to the solution. So whenever alkali metals or alkaline earth metal dissolve in ammonia, they give blue solution, and the blue solution is due to ammoniated electron. So option A is a correct statement. Now we will see option 2. Sodium hydroxide react with glass to give sodium silicate. Now sodium hydroxide react with glass, that is SiO2, to give Na2SiO3 plus H2O. Sodium silicate is formed. So option 2 is also a right option. We look at option C. Aluminium react with excess of NaOH to give AlOH3. Aluminium react with sodium hydroxide and form aluminium hydroxide, undoubtedly. But when it reacts with excess of NaOH, if it is excess of NaOH, it will form a complex of the type Na plus AlOH4 minus. Okay, NaAlOH4. So, if this term wouldn't have been there, then the option C would have been right. When it is with excess, this is the complex that is formed. Therefore, okay, so you are going to get sodium tetrahydroxidoaluminate, isn't it? Aluminate 3. Okay, so this is not the right statement. This is a wrong statement. So answer is option C. We will also check option D. NaHCO3 on heating gives Na2CO3. You know that when sodium hydrogen carbonate is heated, you will get Na2CO3 plus H2O and plus CO2. So this is also right statement. So the only one incorrect statement is option C. We'll go to the next one. Which of the following oxide is amphoteric in nature? Amphoteric means it will react both with an acid and a base. Whether it is stannous, dioxide or oxide, calcium oxide, silicon dioxide and carbon dioxide. So among the 4 options, which is amphoteric oxide? If you take stannous oxide, that is dioxide, and if you treat with HCl, you will get stannous chloride and water. Okay, stannous chloride and water is formed in the reaction. So you can see here, okay, this is 2, right? Okay, so you will have stannous chloride and water is formed. If stannous dioxide react with the base, that is sodium hydroxide, it will form Na2SiO3, not SiO3, we have taken stannous, right? So Na2SnO3 plus H2O. So you will get sodium stannite, right? Sodium stannite. So you can see stannous dioxide can react both with an acid as well as with a base. It is an amphoteric oxide, isn't it? It's an acid as well as a base. So here it is a basic oxide, here it is a acidic oxide. So it can behave in both the ways, acidic oxide as well as basic oxide. So this seemed to be our answer, that is acting as an amphoteric oxide. If you take calcium oxide, we know that calcium oxide is a basic oxide, which will combine with silica and form calcium silicate, whereas SiO2 and carbon dioxide are acidic oxides. Therefore, the possible answer is option A. Option A will be the right answer. Students, you can go to question number 4. Which one of the following molecular hydride act as Lewis acid? You know what is a Lewis acid? Lewis acid accepts a pair of electron, isn't it? Accepts a pair of electron. That is Lewis acid. A pair of electron. Now ammonia is electron rich. So it's not a Lewis acid, isn't it? Water is, oxygen is rich. Whereas if you take methane, it is CH4. There are 8 electrons surrounding carbon. It is electron precise. This is electron rich hydride. These two are electron rich hydride. These are electron rich hydride. Whereas this is electron precise. There are 8 electrons surrounding the carbon. Whereas in case of diborane, it is an electron deficient molecule. Therefore, this will act like a Lewis acid. Okay. So diborane can actually, react with ammonia, for example, and it can form to adduct of this type. So diborane is an electron deficient hydride which will act as a Lewis acid. Okay. Okay, we'll go to the next one. The tendency of boron trifluoride BCl3 and BBr3 to behave as Lewis acid decreases in the sequence. Now just now I told you a Lewis acid is a one which need to accept a pair of electron. So accept a pair of electron. Now if you see boron trifluoride BF3. Okay, boron trifluoride. Now in case of boron trifluoride, students, if you can see here, the electronic configuration of boron is 5, 1s2, 2s2, 2p1, and that of fluorine is 9, 1s2, 2s2, 2p5. So not just these bonds, apart from that you also see the filled electrons of p orbital. See, it's 2p5. Okay, there are unutilized electrons. Only one is involved in bonding. There are unutilized electron in the outermost shell. Only one electron is involved in bonding. All those unutilized electron of fluorine, okay, these electrons will be back donated to boron. Boron has an empty orbital. So this electrons, the electrons which are fully filled electrons of F electrons, they are back donated to boron. So I can say almost something like this. If you are writing BF3, this is giving electrons, so it will have a positive charge, and I can say this is minus. Okay, because it is giving back donating electron. See, when there is a charge like this, Lewis acid means it need to accept a pair of electron. So what happens is, electron accepting capacity decreases. Now there are three examples given. One is fluorine and chlorine and bromine, isn't it? You can see fluorine, chlorine and bromine. Now as you go down, or I can say the tendency to back donate electron decreases down the group. It decreases. Fluorine has greater donation or greater capacity to donate electrons to the boron. That is because both of them are energy levels are same. So the energy difference will be same. As you go down the group, the shells are added up. As a result, the energy difference between the 2p orbital of boron and the p orbital of halogen differs. Whereas in fluorine, their energy difference is very, very less. That is why, students, you will see fluorine has a greater capacity to donate the electron. Therefore, the order will be BBr3, BCl3, BF3. Answer is option B. Okay. The straight chain polymer is formed by. Now, when do we get a straight chain polymer, student? Now, there are 4 options given. We will try with one by one. Okay. So, we will see how do we get straight chain polymer. We can take, I will take one example. Si, the example what you have studied in your class, okay, CH3. This is a dimethyl dichlorosilane. Dimethyl dichlorosilane. Okay. Now, when this is subjected to hydrolysis, you will have HCl removed like this, 2 HCl, and you will have CH3, and this is OH. And this is OH, right? This is dimethyl silanol. Dimethyl silanol. Now let me write the same molecule. The same molecule I am writing. Si. Okay. CS3, CH3, OH, OH. Si, CS3, CS3, OH, OH. Naturally, you will see water is removed. Okay. So, you will have HO. This structure continues. CS3, CS3, O, Si, CS3, I am writing this one, CS3, OH. So like this, a linear structure is formed. So hydrolysis of substituted or dimethyl chlorosilane yields dimethyl silanol, and this dimethyl silanol on condensation will give a straight polymer, a linear polymer of this type, a straight chain polymer. In all the other cases, we do not get a straight chain polymer. So, where do you see this one now? You clearly see option C will be the right answer. Hydrolysis of CH3 twice SiCl2 followed by condensation polymerization. Answer is option C. So thank you, students. Thank you for attending the class. If you like my explanation part, kindly press the like button and also share these videos among your friends. Please press the bell icon to get the notification. My next YouTube class will be on 24th exactly at 2 o'clock. Meanwhile, do not forget to join me for my special class also, that is exactly at 10 o'clock tomorrow. So bye students and take care.